VŠB Technical University of Ostrava, Faculty of Mechanical Engineering, Department of Mechanical Technology, was a solver of the project called Consulting Point for Cooperation Development in the Field of Innovations and Transfer of Technologies. Project manager was Associate Professor, Master of Engineering Josef Novák, PhD, from Technical University Ostrava. Basic project information. You can see on this slide, this project was co-financed by the European Social Fund and state budget of the Czech Republic. Project participants. Project applicant was VŠB Technical University of Ostrava. Project partners, with the financial interest of the budget, Brno University of Technology, Tomáš Baťa University Zlín, Higher Vocational School, Kopřivnice, and the partners without the financial interest, Vítkovice Heavy Machinery and Koma Bearing. Conception of the task. Conception was targeted as follows. The create courses contains the newest worldwide knowledge of research and development, implementation of research activities of partners, efficient and effective cooperation among partners, integration and continuity of the issue, to create a consultancy point for involved parties in these fields, research and education, industry, or other institution. Key project objectives: creation of web information portal, courses aimed to improve cooperation in industrial engineering and other fields, educational activities for better cooperation, creation of knowledge, research and development results transfer, video conferences, seminars and workshops to the issue, creation of a contact point for the public. Solution in connection to the key activities. Information web portal, educational activities for better cooperation and creation of knowledge transfer, conferences, seminars and workshops aimed to deepen cooperation in the fields of industrial engineering. Information at web portal. There is Czech and English version for worldwide information access. Web portal address is cb.forever.cz. It contains the following links: home, brief introduction of the project including its outcome, annotation, courses, multimedia, conferences, collections, testing, contacts. Brief description of the portal pages. Annotation is a link which contains brief information about the following courses: cooperation in CIM, Computer Integrated Management, cooperation in TIM, Totally Integrated Maintenance, consultancy in transfer of technologies and innovations, and building of partner networks. All these courses was created by VŠB Technical University Ostrava. The next courses are cooperation in car industry, cooperation in lean production, cooperation for implementation of highly precise technologies, cooperation for management and programming and machine tools, digital factory, management consultancy. Courses. This link is only accessible to the creators and contains a complex structure and full content of the courses.
Začněte znova, ať to já to vystřihnu.
Jo.
Začněte brief description, jo? Nebo courses, tak.
Courses. This link is only accessible to the creators and contains a complex structure and full content of the courses. People interested in taking the courses can be informed by the main investigator of the project, Associate Professor, Master of Engineering Josef Novák, PhD, VŠB Technical University Ostrava, or by the guarantor of the course. Collections. This link contains full versions of contributions from conferences held by the cooperating parties. Opening conference was in March 2010, VŠB Technical University Ostrava. The next conference was in Technical University Brno in March 2011. Next conference, University Tomáše Bati, Zlín, March 2011, and the last conference was in Kopřivnice in May 2011. The short description about the courses. The first course, Cooperation in CIM, Computer Integrated Management, Preparation. Guarantor of the course, Josef Novák, VŠB Technical University Ostrava. Computer Integrated Management is a complex integrated system for production management supported by computers. CIM is still developed even in the fully industrialized countries. It is the base of building digital factories. For fluent function and total integration of CIM, it is essential to finish work on some other subsystem, database for management, subsystem for work evaluation, etc. A course guarantor is in charge of databases for management, creation, and for subsystems of work evaluation. On this picture you can see the structure of CIM in terms of function of the system and computer support. The CIM consists from activity from computer supports. On the left side you can see the computer supports for preparing of production. It's CIE, CID, CIP, CIQ, and CIS. This supports computer-aided engineering, computer-aided design, computer-aided planning, computer-aided quality, and computer-aided standards. On the right side, you can see the activities and support for management. Is planning of production, management of
orders.
So?
Orders.
Management of orders, NC and DNC, management of machines, and so on. Structure of CIM in terms of function of the system and computer support. I was talking about these supports. Contribution of VŠB Technical University of Ostrava to CIM development. Implementation of database for management, system of work evaluation, assemblies, additional and utility activities, secondary operations times, and transport works, and others. Cooperation in TIM, Totally Integrated Maintenance. Guarantor of the course was Josef Novák, VŠB Technical University Ostrava. TIM is totally productive maintenance integrated into management system of a manufacturer. Currently, there is a range of theoretical recommendations and methodic instruction for implementation of TPM into industrial practice. Solution presented by this project comes from research and development of VŠB Technical University Ostrava, Institute of Design, Organization and Economics of Engineering Production. Requirements of practice were taken in account in proposed solutions. Proposed system of maintenance management is in some of its segments a unique and top solution of maintenance management from a worldwide point of view. Principle and structure of proposed system of maintenance management. Maintenance management system comes from assessment of a current state of devices parts with the help of diagnostic methods. Usage of diagnostic and signalizing systems is a part of current machinery and devices. Application and continual diagnostics or cyclic diagnostics, computer records of all machinery and devices, getting biographies of individual devices and machinery, repair planning with thoughtful preparation, purchase planning, observing and mainly cut down of supplies using the newest methods. Training of operating staff, deepening of cooperation between operators and maintenance during inspection and repairs, regular analysis of functions, individual subsystems, their evaluation and core database check-out. Conclusions for organization of operations, maintenance and repair works, cooperation with outsourced repair services, corrections of DTP and database, projecting of changes into database and other systems. On this picture you can see proposed system of maintenance management and software building. This system consists from information and management system. This system can be different. For example, in this case it's IFS application, can be SAP and other systems. The next subsystem is database, CAS. It's individual, there are individual activity for an object. Diagnostic methods, measured values. The diagnostic can be vibral diagnostic, thermodiagnostic, tribodiagnostics. The next part of the system is real information collection from the production. Microsoft creation documents by Microsoft system, Word, Excel, Solid Edge, and graphic sorting system. It's system for creation of 3D designs by Solid Edge. VŠB Technical University Ostrava contributions for the proposed maintenance management system. Overall concept of the system depicted in the above diagram, graphic sorting system, database and system standardization, and complete software integration, standardization of maintenance technologies, and determination of their workload. The systems are supported by software. On this picture you can see example of application CIS system into practice. Left you can see CIS system, process standards. If I want to apply the system into practice, I must control and selection activities for parallel devices. And this information can be put in the list of concrete activities in IFS system. Standard works. If the devices or machine is new or different, like devices which contain CIS system, we must modification, eventually finishing alternative activities or new devices. And this information we can put into IFS system on the list of concrete activities in the standard works. On this picture you can see example of information determination about maintenance work. We have object of maintenance, for example gearbox, and we can check the burrs. By diagnostic measurements, vibration and oil taking, we must this measurement evaluate, and if the bearing is okay, we can make optimization of cycle and put it in standard works in IFS system. If the bearing is no good, we must go in CIS system and take the standard of conducted activities. For example, for changing of bearing. And this information we can put in the standard work in IFS system. The next course is consultancy in the area of technologies and innovation transfers. Guarantor Josef Novák, VŠB Technical University Ostrava. Transfer of technologies and innovations management are an important tool for productivity and competitiveness of a company, improving and management processes, increase of the growth and efficiency of a company. The importance of innovations in company management system. Innovation is a process of improving company and management system by creation and implementation of company strategy, implementations of new technologies, products, use of research and development knowledge, improving management system, innovations of organization structures according to innovations of product, technology, management methods, and others. Motivational system, human resources management, improving information and IT systems or other specific activities. On this picture we can see innovations and their influence on company prosperity. Innovations, technological, for example, technical, managerial, and others, result the quality, production, management, productivity, cost cutting, overall improvement of system function. The main result is competitiveness, efficiency, economic result. If the economic result is good, it's profit, we can put the money into next innovation. Characteristic of technology transfer. European model of technology transfer usually implies transfer of scientific and technological knowledge from universities, research and development centers, into industrial practice. Along with growing market competitiveness, innovation demands are increasing. Sources for science and technological development are increasing, but the scientific effects do not increase in proportion to invested sources. Transfer of scientific and technological knowledge into industrial practice seems to be a problematic issue. Function of technology transfer. Transfer of technologies has three basic functions. They are the challenge for producer of scientific and technological knowledge, its efficient presentation of research results in practical use, connection to systems of technology transfer for businessmen, for technical and technological development, innovations, implementation, mainly from point of view of competitiveness, for officials of public institutions, for example, governmental, administrative, social, creation of optimal for innovative climate. Brief conclusion of the course content. Innovation and its importance. Transfer of technologies, forms of transfer, current state of transfer, recommendation for better efficiency. Building of partner networks is the last course which was created by guarantor Josef Novák from VŠB Technical University Ostrava. Fight against monopolism and individual gains, which leads to setting business networks between businessmen and research centers. Experience with partners networks indicate the following aims. Creation of partner networks is the part of development of individual production systems and economic systems. Cooperative networks are becoming a tool of systematic coordinator of production and other processes. Cooperative networks are the innovation and management system. Forms of cooperation among business and subjects. Industrial words, cooperative networks among businesses, innovative centers, scientific parks, technological centers and parks, clusters, specific cooperation networks, strategic alliances, outsourcing, insourcing, benchmarking. Brief conclusion of the course content. Sense and significance of building partner networks, forms and means for creation, closer characteristic of individual forms and the area of their use, examples of functions of existing partner networks, supposed effects and advantages. Realization of briefly introduced courses. Guarantor Josef Novák, VŠB, Technical University Ostrava. By Technical University of Ostrava was created the next courses: cooperation in CIM, cooperation in TIM, consultancy in transfer technologies and innovations, building of partner networks. These courses were carried out for chosen groups of teachers and students. For more information about courses, please contact Josef Novák. The contact address and the other contact information you can see on this slide. Thank you for your attention.